Hey everyone, in this class we are going to discuss about how tokenizing text will be converting to a number representation. Basically, like why do we require before we converting to a number representation, what are the approaches that we have, and also why do we require this, we will study today in this particular lecture. So what happens is first, why do we require is, see, when we have a machine learning algorithms, right? So like whatever the machine learning or deep learning algorithms, right? So they expect as an input as a numbers. Okay, so when you pass this to a text, it will not be able to handle, right? So hence the computer requires this as an integer. The machine learning algorithms are designed like, let's say example loss regression or the deep learning algorithms, right? You pass this as a tokens or the numbers. That's why you need to convert them to a number representation. So hence this is one of the mandatory step here, converting to a number representation. And also we can project every token into a dense vector representation, right? So when I say dense vector, right? So dense vector representation. So dense vector is like every token in a multi-dimensional space. You can represent every token as a single vector. So vector is nothing but it's a collection of the numbers, right? So let's say if you plot, let's say in terms of a 3-dimensional or 4-dimensional views, right? So if let's say this woman comes here, okay, and then men comes here, right? And maybe the king comes here and the queen comes here, right? So example, right, you can plot them, and then we can also find the how similar these words are and how how dissimilar these words are, right? So when you project them into a dense vector representation, so we can find some kind of match representation between the words or the subwords, right? So that is what is very, very important when you have a dense vector representation, right? So like why do we require a dense vector or the vector space is basically like to convert them to kind of finding the similarities or dissimilarities. So that is very, very important, right? So finding the similarities or dissimilarities between the tokens. So that is very, very important, right? So then also like in terms of the text, when you are when you have a lot of documents, what happens is when you are representing them to a unique words, right? So the words are like actually it has its own the larger in length, right? So hence what happens is like you can have like 10,000 to 20,000, 30,000 we may get as a unique words, or even more than that, right? So what happens is like when you have these, if you don't represent them to a vector, so it is not like unique. It's not a kind of pattern, like we cannot like this particular documents has a different vocabulary and then that particular other documents have a different vocabulary. So we cannot like match between these two, right? So if you project them into a vector space and then those vectors are like always a fixed length or fixed dimension, then we can match the similarities. That is why it is very, very important for you to represent as a vector, right? So then also it helps you into kind of dimensionality reduction as well, right? So you have example, when I say dimensionality reduction, right? So you have a multiple, as I said, right? So the multiple words will come in like lot many unique words are the vocabulary that you see, right, in the entire documents. So if you have like to represent either in Spanish or English or whatever, like we cannot have like such a larger vocabulary size, right? So hence you need to store this into a memory or fit into a memory. Every token has to represent into a kind of dimensionality, like multiple dimensions, and then that dimensionality automatically it reduces. Like every token we represent them into, let's say 768 or 512 or something 500 vector length. So every vector, so that will be a matrix or the length of the vector space, right? So hence it will tremendously reduce from the entire vocabulary to a dimension that you are representing, like 500 vectors in that length. So that is why it helps you in building a richer dimension as well. At the same time, it also helps you to reduce this dimension when you are representing to a vector representation. So what are the typical algorithms that we have, like when you are studying from tokenizer into a number representation, right? So what kind of representation that we have, like what kind of algorithms that we have is, the first algorithm is the algorithms that we will study now, right? So algorithms is, the first one is the bag of words approach, right? The BOW, which we call as a bag of words, right? So that is one traditional techniques. Like every token is into is every sentence is break down into a tokens, and then every documents has, like, let's say you get a lot of documents, and then you have the tokens, and then you represent to how many what is the frequency of this particular token in the particular documents. That is what is a bag of words approach, and we will discuss in detail. That's no need to worry for you to at this moment. So the bag of words, and the second one is we have, if you see the TF idea, term frequency and inverse document frequency, right? So that is what the second one. And third one, like we do have some lot of deep learning approaches also. Let's say deep learning approaches. So when I say deep learning, they apply onto a neural networks. Like this text will be represented in terms of a vector. The text being is input, and then you get as a dimension as the vector, dimension as the, or the vectors, the numbers as the output. So that those vectors are basically, those algorithms are like, first we start with word to vec, right? And then the second one is we have the ELMO, we have glow, right? And we have transformer based architectures also, like BERT, or maybe Roberta, or XLM, or maybe GPT models that you see, chat GPT kind of, that you must have heard, right? So this is a base version is GPT models. So now you can represent every token as a number representation by using any of these approach. But like, why do we have so many algorithms, right? So first we started with the invention, as started with the bag of words approach. This is very simple, and it is a very easy approach. So when I say easier, in terms of the memory requirement, in terms of the, you know, the way that you understand the complexity is very little less, but and then it is also easier in computation, right? It doesn't take much time. And the TF IDF also, it adds some contextual similarity also. So we will also discuss around that particular algorithm. So when you go to deep learning, right? So you need to represent every sentence of the tokens of every sentence of the tokens into a meaningful vector, ideally, right? So every token, if you're representing, you need to represent as a semantic embeddings or the contextual also, right? When I say embeddings, that is nothing but vectors. Okay, so that is where the evolution started. First we start with the word to vec, every word as a vector represent, word to vector, the meaning itself, right? And then ELMO we have, and then we have glow, and then we have a transformer based architectures like BERT, Robot, XLNet, XLM, or and then we have a GPT, and then we have a T5, lot of models that we have, right? So we will soon discuss all these each and every aspects. What are the advantages, what are the disadvantages? So main advantage that we in these two algorithms, other than deep learning approaches, is you get like very simpler, it is very simple, and then it is easier to handle. And that is where these two algorithms are also nowadays, like even it is used in the industry even now, right? And the deep learning algorithms are much more complex to handle, and then we have a lot of you know, the when you require these things, like you need to have a lot of infra requirement and then memory requirement, so that comes into existence. So when you have like infra requirement like RAMs and then GPUs that you have, right? So then of course you can always free to experiment with this. And if you do not have like a lot of GPUs or the memory that you are adjusted, then you can always go to bag of words or TF IDF. However, that is also good, but I won't say that is outdated algorithms or the something, but still it is used in the industry, and then it is also popular across the interviews when